Good afternoon, everyone. Welcome to the Catalyst Connection webinar in cooperation with Hamiltonian. It's our Smart Factory virtual workshop. This was our take two from the workshop, the in-person workshop that was planned back in March. But for reasons we all know, we've pivoted and are excited to bring you this virtual workshop today. Just want to do a brief intro just on Catalyst Connection for those of you who may not be familiar, and then I'll turn it over to our presenters for today, who will be Ravi Venkatraman and Will Palmer with Hamiltonian here, and then just a couple housekeeping items before we get started. On the GoToWebinar platform, we have a number of handouts, and there will be some polls we do throughout, and Ravi and Will share more about that. But you'll see that on the menus on the side. Some things will pop up. You should have a handout window that shows 4 different files that will be they'll speak to, and we'll get through those. And then there will be some opportunity for hopefully some interaction. We'll have to go through and unmute and unmute yourselves. And in this platform we won't be able to see your webcams, but you'll be able to see us. So here, we'll go ahead and get started. Let's see if our slides want to get going. That always seems to be the hardest for the first one to go. Not sure why. There we go. Okay, so our Catalyst Connection, for most of you are probably already aware, but our focus is advancing small and medium manufacturing across Southwest Pennsylvania through accelerating their growth and productivity. We really focus on that in 3 core areas surrounding product, process, and people. And the key piece that we're growing into is on the technology space that can really cross all 3 of those, and which obviously is the focus of our webinar today, focused on smart manufacturing, smart factory, and IoT. And so just a little bit of how Catalyst supports in the technology space. We really are aiming to provide service and support across the whole spectrum of deployment. So from that early on portion, just initial exploration, which you may be doing today by joining in this webinar, and moving on through provider search and evaluation, through integrator selection in our third-party network, great third parties like Hamiltonian, through implementation and ongoing support. So with that said, certainly feel free to reach out to us here at Catalyst for more information here. So with that brief introduction, again, my name is Matt Minner. I'm a technical consultant here at Catalyst, and then you may also be hearing from you're probably familiar with Todd Tomany, is part of our operational excellence team who runs the Lean Peer Network. He's joined in the session for the day as well. So we're looking forward to a great session. So with that, let me hand things over to Ravi. So are you there, Ravi? And I will make you the presenter, so just bear with me 1 second. Okay. All right, so we're seeing your screen now, Ravi.
Thank you. Okay, great. Thank you all for joining us. I'm excited that we were able to make this happen despite COVID getting in the way of what we were putting together, which was similar content, but there's always something nice about being able to have a workshop where we can really talk one-on-one. So we're doing our best here to be able to meet that and still be able to have an engaging discussion on smart factory and on IoT and digital transformation. So really appreciate everybody taking the time. And I want to especially thank those who filled out our pre-webinar, pre-workshop survey, which helped us tailor the material, and I think was a good self-assessment ahead of these concepts to begin to think about where you are in the process. Thanks also to Matt Minner and to Catalyst Connection for the wonderful work that they do, which Matt just outlined, really tremendous and so valuable to Southwestern PA and to Pittsburgh area. Just to say that the goals for today for this digital workshop is to be able to expose you to the important concepts around IIoT, Industrial Internet of Things, and on smart manufacturing, and then start to link some of the challenges that you may experience or that your company may be experiencing, to be able to link some of those challenges to IIoT use cases or to digital transformation use cases, some of the ways that companies that we've worked with are addressing similar challenges using this new technology, or perhaps not the new technology, but new versions, new iterations, and new applications of the technology. We also are hoping that by the end that you'll come away with some real concrete next steps. You'll see what the project plan looks like, and you'll see that this is sort of a first step, and you'll hopefully be able to have some clarity on the next steps should they prove fruitful and a good fit for your specific situation. And no matter what, we're hoping that in the workshop element of it that we can share where we are in our various, journeys in digital transformation. Perhaps you've already explored IoT. Perhaps you're way far back in digital transformation, still doing most of your work on paper or with older legacy machines, and we'll cover all of that. But we really want to give people a chance to share where they are and be able to see where their peers are, so that we can start digging into these concepts that are most relevant. So without further ado, take the agenda. So just really quickly for what we're going to talk about today, Ravi will be leading the workshop, and we'll first talk about the core concepts so that the terminology is clearly defined, and that we're really exposing perhaps some things you're already familiar with around smart manufacturing and IoT. And then we will talk about use cases, the challenges that people face where IoT really can create measurable returns. And that's specifically we'll be highlighting in manufacturing as well as in operations efficiency. And then some more use cases around measuring product quality and continuous improvement of products. So hopefully a good, I think, distribution of use cases. There are many, many use cases in IoT, many applications for different industries, but I think these will be good to be able to illustrate the example and the type of problems. And then we'll talk about the technology, the architecture, and what to do about older machines, whether to upgrade machines or to outfit them with sensors, how to select sensors, and then the role that AI plays in this path of continuous improvement and IoT. Finally, in the content portion, before we talk, more open up to discussion and to an interactive section, we'll talk about project roadmap. And to that end, you'll see in the panel on the side, I believe, there's some attachments. There's a couple articles which I think probably are you can download and take a look at after the workshop, which we think are going to be really complementary materials. But there's also an Excel workbook which you can open up while Ravi is going through these concepts and use that as a way to start filling in. Perhaps it is a 5-step workbook, and perhaps just the first steps, if you can start filling those in today, I think that would be really, really great. That's about identifying some of the challenges and perhaps some of the operational goals, as well as the roles, and then it begins to dive into the more specifics of actually what would you want to outfit with sensors or to start collecting data on. And so then we'll open it up more to an interactive section and try to have the workshop element to be able to start talking more specifically to your situation. And we also have some other folks on the line who will be able to chime in, and hope that you'll prepare a little bit in the lead up to that to share what your situation is, perhaps some questions or challenges that you want to pose, and maybe you'll hear something that you hadn't thought about that sounds like your situation as well. And so throughout, we'll have a few stops for polls, which you'll see pop up if you can answer those, and we can see what that looks like for the group. I think those will be interesting sort of little self-reflection points, and helpful to see the makeup of the group, where people are in the various on the various topics. And of course, at the end, then, as I was saying, we'll talk about discussion and open up for questions. So a little bit about us, about Hamiltonian Systems. We are in the enterprise application supports and deployment and implementation space, as well as creating technology solutions around digital transformation. We have particular focus on maintenance and manufacturing, as well as supply chain. We work with corporations that are deploying our solutions globally, as well as small manufacturers in the Pittsburgh and other regions that are really looking at how do we make this technology accessible to perhaps 1, 2, 3 plants rather than 20, 30, 40 plants. So really trying to scale down and scale up these solutions. We have tools and software solutions that we tend to customize to the specific use cases, and those are in spaces such as IoT, as well as ERP enablement and extension, cloud adoption, and digitalizing supply chain. And we're headquartered in Pittsburgh, along with Catalyst. Very happy to be partnering with them, and we spread our work team, across the country and world with our development team, both in the U.S. and India. So I will pass it off without further ado to our CEO and founder, Ravi Venkatraman, who has a lot of experience in the industry with implementations of solutions, design of solutions, consulting manufacturers of all sizes. And without further ado, Ravi, take it away.
Okay, thank you very much. Can everybody hear me okay?
Yeah, we're hearing you good, Ravi. If I can just real quick, I wanted to add something just with regards, if anyone does have questions throughout, kind of before we get to any of those poll stops, feel free to use the chat window, or there also, I believe, is a window specific to questions. I'll be monitoring all that. So if you have any questions and kind of hit you at the moment, feel free to pop it in there. And as we talked about, we'll try to get the opportunities where we can have more interactive discussion, as we go through. But just want to make sure, if you have any questions, feel free to pop them into those couple areas there. So thanks for that. Back to you, Ravi.
Okay, thank you very much. First of all, thank you, Will, for the introduction, and thanks to Catalyst Connection and Matt Minner for having this workshop today and asking us to take part in this workshop. So, and thanks to all the participants for taking time out of your time, for taking time out of your work today and attending this workshop. Actually, I just wanted to start here refreshing our memory with some of the terms that we keep using in our discussions today. So we're going to talk about smart manufacturing and Industry 4.4 because this is a smart factory workshop, right? So smart manufacturing and Industry 4.0, they more or less mean similar things related to computer integrated manufacturing and using digital information technology to have digital transformation. So these terms like digital transformation and digital information technology primarily mean that we enable machine-to-machine communication across your locations of your factory. It could be just in one place or multiple factories or multiple locations across the globe, and even your supply chain with your partners and suppliers together. And then we enable Internet of Things, which we are going to see what exactly are this Internet of Things and so on. So those are basically sensors and actuators to capture data, and with that data, we are going to increase automation, and then we are going to increase self-monitoring, And as your evolution on the Industry 4.0 map keeps growing, you will see that your machines are getting smarter and smarter, and those machines are able to analyze and diagnose issues without the need for human intervention. We have some more terms here. Connected devices. A device connected over the internet, which is able to send and receive information, is a connected device. So the smart device is taking it a little bit further. It is able to reduce the workload of a human being in some form or fashion. And then the digital twin, this is a term which really means like having a twin in the virtual world. So it's an up-to-date representation of your physical asset, which is sitting on your factory floor, which is enabled by IoT. And this concept could be extended even to the products you make. And so the digital twins could be your own assets as well as the products you make. We are going to see some of the examples as we go through the slides. And simulation is a process of doing what-if analysis without actually providing the input and output. The whole thing is done digitally in a manner. You just provide the required input to a process and you get the output, and you are able to visualize the alternative conditions of what inputs provide what kind of outputs, and then any insights into the courses of action. And then we talk about the IoT device. An IoT device is a connected device. It is also a smart device. In addition, it is defined by a software product. It's a software-defined product associated with it. It could have a digital twin, but it will have an application. It will have analytics, and it is connected through internet. So the next question here is, what is IoT and what is IIoT? Is there a difference between these two terms? So an IoT is nothing but a connection between physical entities through a network and with the digital world interacting with each other. So these objects could be across the globe. It could be within one single location and so on. Then what exactly is IIoT? IIoT is nothing but IoT applied in the context of manufacturing and industry. Okay, so here in IIoT, the physical assets like your trucks, your forklifts, and all the big equipment you have, each one of them can be connected, and then we call it as IIoT. So during the presentation today, I may be interchangeably using the terms like IoT and IIoT, but the context certainly today is IIoT. And it means, either way, it means the same thing today. Okay. So if you see this particular graph, the spending on the Internet of Things on various sectors, starting from your discrete manufacturing to process manufacturing, retail and government, you can see where the spending was in 2015 and where it is now. So if you see the first one here, which is a discrete manufacturing, it was $10 billion in 2015, and in 2020, it was expected to be $40 billion. This is, of course, pre-COVID numbers, and even if you provide some adjustments, it could be $35 billion. Still, it is it's like a 350% growth over 5 years. And the same thing is with all the other sectors. So it is a growing market. IIoT is a growing market. So in today's world, being competitive and able to operate in a lean fashion is essential for survival. So some of the immediate gains from implementing an IoT project or your equipment uptime and the efficiencies in your supply chain and your production operations, and also savings in your business expenditures, and then saving in the margins. So with that, you are able to pass the benefits to your customers, and you are able to be competitive. So as we saw in the previous slide, increased efficiency is one of the opportunities. And we have a lot of data coming in right now from all kinds of sensors and other areas. Okay, so you are able to drive your decisions. So your decisions are based on data. So your company will transform into a data-driven company, And then we are able to maintain the agility in our production and maintenance operation. Depending on the market situation, you can quickly adapt to those conditions. The product quality improves. And there is one huge opportunity about productizing your services. This is something, which has come new as part of the digital transformation. We can talk about it more. It may or may not be applicable in all the situations, but your services, how can you productize them? Okay. As with any other project, there are always risks. Okay. So it could be, it could seem like the initial investment in an IoT project could be huge, and it could be a non-starter. So typically what we do is we just go through the use cases and then analyze those use cases which are giving the biggest bang for the buck, and then start small and then grow into that slowly. Okay. Then the same thing with the business and IT buy-in. This is a very important topic. We should have the executive buy-in for any of these projects, and there should be collaboration all across the organization, at the top level as well as people at the shop floor. Okay. The security and privacy is always an important topic these days on IT, as well as the IoT projects. And if you bring in a right partner who knows how to implement these projects and the support and the know-how they have on IoT, the risks below are mitigated. The implementation challenges and the know-how and the support risks are mitigated by bringing the right partners. So the next slide is about the use cases in manufacturing. There are lots and lots of use cases in IoT in manufacturing. Here we have listed 21 of them in 5 different buckets. Those are the manufacturing operations, the maintenance operations, and 2 buckets for products, product quality and product design, and there is one on service operations. If you look at the manufacturing operations bucket, typically these use cases cater to production operations efficiency and workforce safety and employee productivity and so on. When it comes to the maintenance operation, the purpose of maintenance is to ensure that your assets are available and up all the time. So asset uptime is the main use case for maintenance operation. But how do you go about doing it? It means like you have to know when to do the maintenance. So we talk about predictive monitoring and implementing predictive maintenance systems, right? So you just go ahead and fix the issue even before it happens. So those are some of the maintenance related use cases. Then when it comes to product quality, we see like a lot of companies getting, like scrap. So a scrap is typically what happens is you already make the product, you just add all the value to the product, and finally when it goes through, when the product goes through the quality control, then it is scrapped. So it means there is a lot of money put in, effort put in, and finally it's scrapped. So which is like a total wastage. This IoT can help improving the product quality, okay, which we are going to see in our slides. And then over a period of time, with the data coming in from your process analytics and product analytics, and linking those areas and parameters, we are able to optimize our whole flow of how do you manufacture a product, as well as what kind of process you use. When you optimize those things, you get the best quality products. And then product design. Typically, we all make products with a certain thing in our mind, because there is some end user or another company which is going to use this product. Okay, so we want to ensure that they get the best value out of these products. So by developing product analytics and bringing in data from the customers, we are able to make changes to our product design and make better products in the next version and so on. So what exactly is driving the need for IoT and digital transformation? So we talked about, like getting ahead of competition is one of the things, operational efficiencies and profit margins to reduce the cost. And one of the major things is your customer relationship improves and your customer service improves. So your customers are happy customers and they come back to you again and again to buy your products. So here we're going to discuss some of the use cases. The first use case is about operations optimization. So when I take operations optimization, this is about like collecting data from your plant floor from certain assets, and you will see that this particular use case can improve your production operation as well as your maintenance operation. Okay, so let's say you have a motor like this, and in this motor, if you are embedding sensors, and the sensors are constantly spitting out data, and you have thresholds for each of the sensor data. So when the threshold is within some limit, it is going to show you green or no fault. And when the threshold reaches certain other values, either it is going to show it's whether there is a minor fault going to happen or a major fault or a critical issue. Okay, so as soon as these kind of limits are reached, you are immediately able to take action. So that particular action can come to you in the form of a text in your smartphone, or it could be a work request or a work order, and immediately maintenance person can be dispatched to fix the problem. This is known as the first principles modeling. And as the data keeps coming over several months and years and so on, so there is an opportunity for us from moving from the first principle modeling to the data-driven modeling. So in this example, what we are doing is we had all these sensors, okay, from where the data was coming, and then we are able to immediately attend to any of the problems. Okay. However, we are taking a particular piece of data, which is a noise measurement data from the pump, and then we are using a machine learning algorithm called Kalman filter, and with that information, it is predicting an estimated state of degradation of this particular pump. So in this degradation model, we are using simulation. So it means like we are changing the input multiple times and see how it is going to degrade. That is why you see all these blue lines going on here, right? And then with all that, the machine learning is able to finally predict using the simulated model one particular value, which is like the red in color here. And it tells us that the estimated remaining useful life of this particular pump is 121 hours. So it means in that time, you need to act upon it and then fix the issues with the pump. So either it could be just maintenance alignment, or it could be ordering a part, getting the part, and then fixing the pump. Okay, so then you can work with your production team to get a maintenance slot to fix this issue. So you are able to identify the problem as they happen, or predict when it is going to become a major outage, and then you are going to prevent the outage. So your production continuously it moves on, and the production efficiency is optimized. So when we talk about the maintenance here, we have a lot of customers, even big Fortune 500 customers. Sometimes when we go to, we find that like their maintenance is very reactive in nature. Though they have though we implemented the preventive maintenance programs and everything, moving from reactive to preventive maintenance has been very tough, because they just use only the equipment data. So if they get additional data, and if additional work orders and everything are generated, people are willing to work on that. But only thing is with the limited data, you are not able to move forward, right? So the condition-based data, it is, in order to do that, actually we have four items listed here on the top. It says equipment, sensors, process, and artificial intelligence and machine learning, let's say. So these four items are used in moving from preventive to condition-based, and from condition-based to predictive and prescriptive, and so on. So for condition-based, we are saying you will use equipment, sensors, and process. And for predictive and prescriptive, you will use all the four methods. So once you start moving up the ladder, you will automatically see that you are able to predict. If you are getting like right data, and then you are able to use these models, you will automatically see that your maintenance maturity is going up. So in the previous example, we talked about efficiency, production operations optimization and maintenance operations optimization. Right now, I want to introduce to the concept of the digital twin, and we are going to talk about business to consumer scenario here. Okay, this is I just brought this example because this just talks about digital twin and also the use case in servicing your customers. We all use washing machines at home. Actually, this is a story from my own life. A few years ago, like 4 to 5 years ago, my neighbor bought a washing machine, and he had this company. I'm not going to name that company for servicing his washing machines and refrigerators and so on. So one day, the washing machine had a big leak, and there was water everywhere in the house. He was very upset. Then he calls this company, and that company is not able to immediately schedule an appointment. They gave him an appointment after 2 weeks. They just told him, just shut off the water. That's the only thing they gave at that time. And in 2 weeks' time, they come and take a look at the washing machine. And then they say they need additional parts to fix it. So they order the parts, which comes another 2 weeks. And then the whole issue was resolved in 4 to 4.5 weeks. Whereas imagine if you have sensors embedded in this washing machine, and the washing machine is seeing some leak. Even before the leak becomes big, it can text or email to the customer saying that there is a potential issue, and the solution is to shut off water, right? And it can immediately send a message to the service provider to create a maintenance work order. And also, there are other data coming in. It's not just one sensor from the leak, right? There are other sensors in the washing machine. So all this data can go to the service provider, and then it can tell what kind of parts are needed, whether other parts are okay or there is another issue going on. So with all this information, and if the parts are available, they can call the customer, and they can schedule a time, and they can come and fix the issue. So you just resolve the issue in your first visit, and then you are calling the customer saying that, hey, I want to come and take a look at your washing machine, and the customer is not calling you. Okay, so this is one of the major advantages of digital twin, embedding your sensors in your product. But however, this is like a consumer product. What happens in an industrial product? Is it possible? And the answer is yes. So here I'm showing the use case of Rolls-Royce. Rolls-Royce makes this aircraft engines, and they always used to get complaints from this aircraft companies, right? So what they have really done was they started embedding sensors in their engines, and those sensors start collecting data, and they not only collect that data, then they ask the customer to provide other data which happens in the same time. It is like a time series data, right? As they are flying, as they are taking off, as they are, at 40,000 feet, what happens? So they get the aircraft data, they get the other engine data, plus the engine data, whatever they have. So they collaborate with the customers to get the data at a frequency which is acceptable for both of them. And then with that information, Rolls-Royce can predict when the engine needs maintenance. Okay, though there is a process for scheduled maintenance and everything, they can tell you to go ahead and do additional maintenance even before the engine fails or something bad happens. And at the same time, they're using this data to build better engines for their next version of the engine. They're using this data to rectify the design flaws and build better engines. Okay, so is it possible only in the case of like Rolls-Royce? How can like your company collaborate with your customers? Here is another example. We have been talking to them in the last 2 years. Actually, this company got a lot of complaints from their customers. It is a chemical manufacturing company, and their chemicals are used by their customers to make their products. So they have very strict quality control of how their chemical is made, how their chemical is packed and shipped and distributed and all that. But however, when they get these complaints saying that their chemicals are bad, they don't know how to handle this issue. So they decided how they can collaborate with the customer. So in this particular case, what they want to do is they thought that our customers are not using the chemicals in the way we are asking them to use. The operating conditions are different, right? So they want to understand the operating conditions of how the customers are using these products as their raw materials, right? So they are embedding sensors in customer sites and collecting data from customers. And with that data, they are able to find out process flaws with the at the customer side, and then they are collaborating with the customers to improve the customer processes. Though their chemicals are good, the process was bad, which had a totally bad outcome, right? So they are able to collaborate with the customers and improve the customer processes to make their products work better, and the customers are happy about it. And then there is another local company here. This example is about product quality improvement. Okay, this is a use case on how to improve your product quality, keep it, and then optimize the quality for in the long term. Okay, so this company produces fiberglass sheets, and interestingly, they had embedded sensors in their equipment using PLC systems. They collect like more than 4,000 pieces of data from all their equipment. So the very first equipment produces around 150 to 190 pieces of data, right? But right now, what they did was, they have all these pieces of data, but when it comes to their quality data, they were just taking manual measurements, and it was not adequate enough. Okay, like it was very less, and that manual measurement cannot be connected with the data, whatever they already have from the PLCs and the sensors. So as an example, they take measurements, let us say, on the melt pressure, viscosity, and melt temperatures, and so on. These are some of the examples out of the 190 pieces of data which is coming out of the first machine, right? So even though they have all these things, like the time series data about all this, they're not able to connect it to quality. But with the vision system implemented, the vision system is able to take the thickness of the sheet every so often, maybe every feet or every 2 feet, and so on. And with that information and this information linked together and combined, they should be able to make product quality improvements. But however, whatever data they have today, is it useful? Yes, it is useful, because that data can correlate within itself. Like, for example, does a particular additive need high pressure to flow at a specific viscosity? So here you have the additive information and the viscosity information. Then you can see, whether it is flowing or not. But what they cannot answer is, how is the thickness of the sheet affected by any of the listed parameters? And that they would be able to answer once they are implementing the vision systems. Then like they have the whole 9 yards, and they're able to make improvements in the quality as the sheets are flowing through. If there is a problem with the thickness, they can immediately rectify it, and further they can use the data to optimize their process for future use. This is from one of our customers who makes paints. This particular use case is actually from 2012. It has been like 8 years we implemented this particular use case. So in the paint manufacturing process, there are 4 main ingredients you need to add to make paint, and obviously they are stored in different tanks, and you go and mix them, right? So what happens is, since this is process manufacturing, they have to mix it at a particular volume, like of product A, B, C, and D. They're mixed at a particular volume, and they're all stored in different tanks. So each of the tanks have a valve where the material flows through it. And this valve, if they say, like for 15 minutes it can flow, and then the valve needs to close. So they have a timer for all that. But what they were measuring was, the valves were not closing on time. The valves were closing, like sometimes it closes between 6 to 10 seconds, sometimes in 20 seconds, 15 seconds, and so on. So which was affecting the quality of their products. So what they really did was, they started measuring the time of valve closure. First, like they are able to give an alert. Let us say this particular valve needs to close between 6 to 10 seconds. They will measure that, and if it is exceeding, they will know that. right? So with that information, whatever they have, they are seeing the trend, the time, taken by the valve, whether it is sticking to the threshold or it is slowly increasing from 6 to 7, 7 to 8, and 8 to 9, and so on. And then accordingly, they can go and fix the issue before it becomes a quality, before it creates a quality problem. So I have a small video here on predictive maintenance, and I'm going to talk through as the video goes through. I hope you're able to see my video.
Well, it's starting.
Yeah,
I'll post the link in the chat as well in case it doesn't come through.
Okay. So what this really talks about is there is a sensor which is embedded in a factory floor for a particular bearing. Okay. And then that information goes through their immediate control monitoring system and also to the cloud. Okay. So at a point, this information, like it says, that is getting bad. That bearing is getting bad, and this information is showing warning, okay, at their dashboards, and the information is also flowing to their cloud. Okay. So in the cloud, what happens? They have their ERP system and your regular IoT system. So since it is linked to the ERP system automatically buys a bearing, okay, and that information is coming to the technician that the bearing is coming in 2 days, and in 2 days the technician is able to receive the bearing, and then they come and put the bearing here and then fix the issue. If you really see, all this happened before it caused any problem, and the whole thing is people have data about all this, including the supply chain data, moving the data into your ERP, ordering the part, and the information comes to the technician, and the technician is able to fix the system and so on. I'm just going to close this. So the basic idea is the IoT solutions, the use cases, can be integrated with your other applications and with the entire supply chain, and then the information can flow back and forth pretty quickly, and then like all the actors are part of that information flow, and they have the necessary information to act and then fix the issues. There is a poll right now.
Okay, so yeah, if again, if anyone has any questions, you feel free to put them in the chat, or you can always, there should be a, you can, the raise your hand icon, and it'll be easy to unmute folks too if you'd like to ask your question. But here to start, we've got a poll question surrounding, what areas you may be challenging, or you may be looking to, implement IoT. So obviously this is, geared towards those in manufacturing, but if you're not directly in manufacturing, feel free to vote for what you've seen from whether it's clients or other observations you've made. So I'll leave that open for a couple minutes here, or not a couple minutes, I'll be a little long, another 10-20 seconds, give folks a chance to take a look and cast their votes. Let's see, we had 40% vote so far, so we'll give it another few seconds. Okay, well, there's 50%, and okay, we'll go ahead and call that one. Okay, so yeah, for that we had half our participants voted there, and had the most votes for manufacturing and maintenance operations, with their 20% for product quality as well. So I think the bulk of the interesting, like everybody voted for that manufacturing and maintenance operations bucket, Ravi.
Okay.
Okay. Oh, and look. Oh, here we go. There's, although it doesn't say how many people voted, but there you get to see the results as well. let's see, I don't see any other questions at this point, but here we'll go ahead. We had one other that we were going to take a moment to do, and that's regarding where do you see the biggest obstacle to implementing IoT, for your company. And again, if you don't have the direct experience with that, to share what you may have seen from manufacturers you've worked with. Okay, I'll give it another few seconds here. And then I think I'll try, because there's I think some interesting results here. We'll try to unmute folks if anyone has any comments or anything they'd like to share. And that looks good. We're up to that 50% mark again. So we'll close that. And so here you see, justifying the expense is the biggest challenge, followed by the actual, hardware, getting machines fit up with sensors or the networking infrastructure. But we do have, others. So certainly would be interested to hear from anyone who'd like to share. So let me just give me 1 second here. Attendees, let's see. Okay, so now I think everyone should be able to, if anyone would like to make any comment, have a question, you should be able to unmute yourselves at this time. Let's see. Yeah, so, okay. So yeah, then if there's any other questions or anything, I certainly posted in there. I don't know if that's working or not. So we'll hand it back to Ravi here, and we'll keep working on that for the next one as well. So let me close that. Oops. Polls, there we go. So getting around everything. Okay, so it's back to you. You should be able to share again, Ravi. And then just to keep a note of the time, we're at 1:48, just so we make sure we're getting through to allow time for our the workshop portion.
Yeah, I am able to share right now.
You should be able to. So try to. Let me make sure you're
okay.
Still a presenter.
So are you able to see my screen, the poll window, which is IIoT architecture? Are you able to see mine?
Let's see here. I was, for some reason, it's big. You do have control. Are you sharing again? You may have to reshare to share your screen. You do have control.
1 second. Okay, got it.
There we go.
Okay, are you able to see my screen right now?
Good to go, Ravi.
Okay, thank you. Thanks to all of you for polling the result. So Matt, we will discuss this, like maybe in the end when people have questions, okay, on that, and we will be able to discuss the poll results then. Okay, so the next topic we are doing is IIoT architecture. Okay, so when we talk about the IoT architecture, again, we get some terms which we use quite often. So I wanted to go over those terms. So first one is MQTT. It is called the MQ telemetry transport. It is it's a protocol. It's a messaging protocol which was introduced by IBM a decade ago, where there is a publisher who publishes all the messages, and then there is a subscriber who subscribes to those messages. So devices can publish, and there is a subscriber who subscribes to those messages, and they'll know what message based on the device type and the device ID. They'll get only those messages they need. So this is a very lightweight protocol, and it is gaining popularity now. And then we have this thing called the IO link. It is it's an open communication protocol, and it is very popular among the sensors and actuators which we use today. Then Modbus is something which people may be familiar with, whoever has used the programmable control, programmable logic controllers, the PLCs, and then the SCADA is basically it's a set of like software and hardware elements, primarily used for supervising your manufacturing floor through monitoring and then processing real-time data and taking action. Then we have something known as the OPC UA, which is the Open Platform Communications Unified Architecture. This term will certainly pop up in a lot of cases when you implement IoT. It is primarily a communication method between machine to machine and a machine to computer. Okay. The HTTP we all know. We use Google Chrome and Internet Explorer. That HTTP web browsers use this protocol. Then the next protocol is called the REST API. This is primarily, it's a REST web service. It's a lightweight web service where you go and ask for the information in the web service, and you cannot get anything you want. The web service provides you only certain data, but you need to be authorized to get the data. So REST is one of those protocols. And then there are other terms, typically in large manufacturing environment, like your oil and gas, and even in the smart cities and all that, you will hear of the things called the web of things and the semantic web of things. Okay. The final thing, the mashup web application. This is a very important term because all the applications you see today, they're all mashed up web applications in some way or other. The content is not it's not like straight. See, the content which comes to your web pages, right? It could be an audio file, it could be a video file, it could be like structured data, it could be unstructured data, and even within structured data, there could be like lots of structures, right? It could be like a text structure or a HTTP and so on. So a mashup web application it is able to get all this information and then finally show it to you in a nice fashion in a single graphical interface. So now we move on to sensors and actuators. There are basically three components for any IoT implementation. So the first one is about the sensor and the actuator. Without, they're also called devices, okay? So without a sensor or actuator, we cannot actually implement the IoT project, okay? So what exactly does a sensor do? A sensor collects some useful information from your equipment or from the environment, and then it is converting that into a data signal. See, these electrical data signals typically could be like an analog signal or a digital signal. So, and then you take the signal and you start working with it, and then we analyze the signal and do something with it, right? So an actuator does exactly opposite of what the sensor does. It gets the signal from us, and then based on the signal, it is going and making some changes at the device. So it can tell the device to reboot, it can tell the device to shut off, it can do anything like that. So actuator does exact opposite of what sensor does, okay? So these devices are useful to start your IoT projects. So on the left, I have listed a bunch of sensors, starting with the acoustic sound vibration sensor. You can have the regular sensors we see in our life, like the temperature sensors, the humidity and moisture, and so on. Okay, so when we are on the road, we have the position, presence, and proximity sensors. Okay, our cars start beeping when another car comes close to it, and like you have the GPS sensor and so on, right? So there are lots and lots of sensors. Only a few are listed here. And these days, since we are talking about Industry 4.0, okay, the German company Bosch and also other companies are making special sensors. They call it as the Industry 4.0 sensors or the IIoT sensors, okay. This sensor, what you see here, it is a collection of 8 sensors, okay. And they advertise it saying that this sensor is useful for condition monitoring. It could be useful in your digital twin. And then they call it as a machine doctor because this particular sensor can get the data about the health of your machine, and then it can show it to you. And actually, the coolest thing about it is it has Bluetooth connection and it also has USB connection. In fact, for our webinar in March, I had the sensor with me. I wanted to come and show how it worked. That was pretty cool thing. And this sensor also has an IoT app. Sorry, it has an app for your iPhone, okay, and also for your Android phone. So as soon as you connect the sensor and you just download the app through Bluetooth, it is able to get the data and show it to you on your iPhone. Okay, so this is one of the very useful sensors, and more sensors like this are coming for Industry 4.0. The reason I'm showing this is because such type of sensors may be useful in your projects to do multiple things as opposed to just one thing. Because it occupies less space and it can do more things. There is a poll now.
Okay, so yeah, we'll put one up here regarding, so we're wanting to do the edge computing. Is that the one you'd like to put up now, Ravi? Okay.
Yes.
So we have this poll up, and then also at the same time, while you should be getting that shortly, you guys highlight in the chat where we're also interested in that previous poll where we got some person who's talking about the network infrastructure as well as another challenge to overcome to implementing IoT. So if you have any further feedback on that, you can put it in the chat, and we can unmute you if you'd like to share.
Okay. I don't see anything on chat.
Yeah, I'm just adding that in now.
Okay.
Just letting people vote here. Okay, so yeah, I just put that message in chat. So if you want to share as far as the challenges with our prior poll, who said other, what other were you talking about, or what hardware or network issues? We'll go ahead and close this one. That's been going for about a minute. Okay, so these results, we've got, kind of across the board, a little bit yes, no, and I'm not sure. Now, it may have been, 1% in each. So
okay.
We'll hide that back, and then the next one that we have here is regarding, what you may need to do if you want to capture data that's relevant to you. Do you need to add, additional sensors? Do you already have access to the data that you're, wanting to use? It's just a matter of how you use it, or is it, a challenge to actually access that data? So we're getting a few votes coming in here, so we'll wait for another 10 seconds. Okay, we'll close that one. And here it looks like we got a little bit of a mix of kind of yes in certain areas. So some definitely have it, and some just for some assets. So I think that's where the discussion on the retrofit or replace, and some of that discussion later on will be certainly valid and applicable. So
okay,
hide that one. So yeah, we've gone through there. Was there anything else you wanted to highlight, Ravi, or Will?
Not right now. I don't see the results. I think maybe we can just proceed and then talk about it in the end.
Oh, well, yeah, here. I thought I had hit it, just lost track of it. So yeah, there's the results from this recent one. And so yeah, you're sharing again, so you can go ahead.
Okay. Okay, so the second important component in the IoT implementation is connectivity. So when we talk about connectivity, like we all have some type of an internet provider at our home. It could be like a Comcast Xfinity or Verizon or so on, which is like a wide area network. And then once that wide area network, it comes to our house, then we use our own Wi-Fi router, and then we are connected within the house using Wi-Fi, right? And then we have, like some of the equipment, some of the devices today, like for example, if you have a Bose speaker, right, it uses Bluetooth technologies to connect to your iPhone or to your laptop and so on. So here we have listed, like lots and lots of technologies which are used primarily for connectivity. And when you are on the road, let us say you are using your GPS, using your smartphone, then you are using either a 4G or LTE network. And then, like we've been talking about, like moving to 5G and so on. Sooner or later, it is going to come to us, okay? And all the phones will be like 5G-enabled phones. So the basic idea is there are different types of connectivity. And when to use what connectivity, it depends on the application of the device and also the device type, okay? Some devices are fit for Bluetooth, some devices may be Wi-Fi, and some devices have to be hardwired through an Ethernet cable and so on, depending on the type of application, okay? So, and the bandwidth needed for the data to flow in and out of the device, you have to provide the connectivity. So that is one of the key for success in the IoT implementation. And then the third pillar or the third component of this IoT is about people and the process. So actually, people are the ones who are actually transforming the digital industry, okay? So if you give people the right type of data, then they are able to visualize newer ideas. And then with like they're able to collect data for those ideas and then validate that data, validate those ideas using the new data, whatever is provided. And we are making changes in the processes. We are transforming processes for improving your efficiencies, your quality of the products, and for customer alignment and so on. So if you really see, IoT is in all these kind of areas. It's in control and automation. It is remote monitoring. And then it is also in analytics. It is also in customer relationships. So it is integrating people, process, using the connectivity we talked about, and the devices. So these are the major components of any IoT implementation. Okay, but how is it all laid out? Okay, it is laid out like what you see in this picture. This is a pretty busy picture. I have broken this picture into two in the next slide. So on the left of this on the left you see industrial edge connectivity, and then you see the Internet of Things cloud here in the middle. And then on the right, you see these applications. Typically, the applications are your ERP applications like your Oracle, SAP, and then Microsoft Dynamics and so on. It could be even your own custom application or a third-party application. So you're integrating the device within your own edge, and then and into the cloud and with your application. So this is like an integrated IoT architecture. So let us talk about the edge connectivity. Like people use these terms like edge computing, and so on. What exactly is edge computing, and do we even need an edge computing? Okay. So in edge computing, we talk of three things happening. One is like the level one is sensing using the devices. Like the devices could be like attached to your equipment, or it could be like a standalone, like a camera watching from a distance, all these things, right? So these are the devices, and they are connected to your internal servers, which could be something like an IIoT gateway, or it could be like a Modbus SCADA server or OPC UA server, right? Or it could be like a historian, which stores all the data. So now this portion for doing the level one sensing and the supervisory and operations management, this falls within the edge computing. And then the data which is available in the edge, it flows to cloud using the internet providers through your Wi-Fi or Ethernet or cellular network through these kind of protocols, like which we talked already about, like the MQTT protocol, HTTP, REST APIs, and so on. But here, why do I have to keep the data in the edge if I can send it off to the cloud? That's a very valid question, right? And also, is there a need to keep the data in two places, in the edge and in the cloud? The answer to this depends on the situation. Okay, the first situation is, let us say you are a company, you don't want to send some information in the cloud. Like for example, you may have an application which takes care of the formulas or the recipes, okay, of your product, which you don't want to put it in the cloud and you don't want to share it, okay? However, you need to connect that information with your information of the devices. Then you will prefer edge computing. So it means, you can still have cloud computing. You can pass some portion of the data coming from the devices to the cloud, but you want to make sure that there is enough data here which can continue to talk to your applications and make decisions right then and there quickly, right? And the second thing is the speed of the transaction and how quickly you want a decision to be made based on the data which is being collected. Like for example, a camera, right? A camera is bringing in information, and then let us say there is an intrusion into your building or something like that. You don't want it to go into the cloud and come back. It may be quick enough, but it may not be quick enough for you to act on that. So in those cases, we have the images and everything. Let us say for the first 2 hours of the camera operation, you want to have it in your edge. And after the 2 hours data is done, it can be pushed off to the cloud and so on. So you will make these kind of decisions based on your security and your speed of the transaction and so on. So then you will have edge computing within your firewall. Okay, it is like having your own server and firewall and so on. Sometimes it so happens, right, the network connectivity goes off, right? So if the network connectivity goes off, you are not able to talk to the cloud, right? So if you have data within the edge for the first hour it is collected, or the second hour, for 2 hours the data is retained in your edge, you can take decisions there quickly. And then when the connectivity comes back up again, you can send it to the cloud. So that is the need, there is a need for edge computing, and it is basically based on how do you want to use it and what kind of use cases you have. Okay. Then when we talk about the Internet of Things cloud, which is called the IoT cloud. So the IoT cloud, it has again the device data, which is the sensor data and the actuator data, and between the device and your edge, what is the kind of communication it has. So it has all those kind of data, and if it is a digital twin, all the data which is coming from your products or from your equipment, everything is coming here, right? So the data is getting collected here. A large amount of data is getting collected in the cloud. Okay. Then using machine learning, you may be doing some processing and then coming up with some algorithms and results, right? So if the good thing about the cloud is, let us say you want to train your model in the end of the month, which is like on the 30th of the month, you want to train your model. So to train the model, you may need additional CPU power, additional GPU power. So for the first 29 days of the month, you don't need that. For the last day of the month, you need additional power. So you can immediately provision that additional power in the cloud, get the model trained, and as soon as the model is trained, you can shut that off. So you save money that way. So you need the power of the cloud and also the power of the edge computing to in your IoT architecture. And the third portion, as I said, it's all about your ERP system. We will collect them. We will connect and integrate the ERP system with your IoT systems. So one particular thing I wanted to talk about is the IO-Link communication hub. Okay, so these are the hubs which are available today. Actually, one of our partners, Pepperell and folks, they make like sensors and they make these hubs. Okay, so the good thing about the IO Link communication hubs is it kind of like demystifies a lot of things when it comes to integration. Like, for example, if you have PLC control, right? How do you connect the PLC control to your other pieces of information and then send the data to your edge servers and to the cloud? Okay, this is like a very big operation, and there is a lot of work which is involved. Okay, the same way, you know, like how do you get something from a PLC control, change it into a MQTT message, and then send it over to the cloud? So these kind of questions will come up when you are trying to integrate. So if you use an IO Link communication hub, it kind of like makes things very easier with least amount of programming and least amount of configurations and so on. So these hubs can read and write back to your PLC control system. They can talk to OPC UA systems, and they can send and receive messages in multiple formats, including MQTT. Okay, so the most important thing in anything is IoT security. Security. Okay, we all know the value of that, and every day we get all these calls from multiple people. I get calls saying that my social security number is hacked, and I know that it's a bogus call, right? And my 10-year-old, all the time he says he got scammed when he's playing a video game. He's having this video game money, which is like points, and he's trying to buy something, and then he buys that, but he doesn't get exactly what he wants. They say something and they sell something else. So every day he says he's scammed. So like that, you know, there's a lot of these bad things going on, and there are digital actors, okay, who are very powerful and who know how to manipulate the companies and the data. So the most important things in digital disruption could be your intellectual property could be stolen. Your data could be accessed. It could be extracted by them, and it could be used in a way which you don't want it to be used. And in the worst case, they can even take control of your environment. And let us say you have set up your process with particular parameters and for improving the quality and everything. But if these people take control of the process, they may be able to go and change the parameters sitting somewhere in different parts of the world, and then you get like bad results, right? So these are some of the things which we anticipate, not necessarily it'll happen, which we need to anticipate, and then we need to work on preventing them. So when we talk about data, I just wanted to throw, like what kinds of data we are talking about. We have audio and video files. We have just sensor data, which are raw data and interpreted data, and the biometric data, which is like your personal information, right? Then you have the other kind of data, the logs and the network data and so on. So any of this data could be potentially hacked by these people, right? So there are three components to get your IoT security in place. So first component is the device integrity. This comes from the device manufacturer itself. So when they make a device, there is something known as an immutable root of trust. So it kinds of like put a stamp on what kind of a device it is, from whom it is coming, and it has its own unique ID. So when you build an application, whether the application is in the edge or whether the application is in the cloud, when you pass information from this device to the cloud and then get back and forth, the device integrity, the root of trust, should be always validated to make sure that the data is secure. And obviously, these people are making with encryption. There is a lot of encryption methods which are being used. Okay, so the next one is the data confidentiality. So whenever you are sending data, okay, so the data at rest, the data at motion, the data in process, all these data need different kinds of security measures. Okay, so if you one thing I have been reading about security, I learned that more than 50% of the hacks happen because people do not change the passwords. Let us say you go and buy a router from Best Buy, okay, like a Linksys router or a Cisco router. It comes with a general admin password and a user ID, like admin welcome kind of a thing. And typically what is happening is people do not change that. They go and implement their IoT solution and everything seems to be working. And suddenly one day, things are getting hacked because people did not change the password. So it is very important that all the passwords, not only on the routers, but also on all the devices, okay, should be changed for security. That itself will prevent most of the security violations. Okay, and then finally the operational assurance. This is a very, very important thing because people access like your devices, your computers remotely, which is happening every day in all the companies. So you do remote provisioning of like your servers, and the same way the devices and so on. So we need to ensure that our operational procedures are built with appropriate security, that like we are safe. Okay, so these are the three components of the proactive IoT security policies, which should be reviewed by your networking team before you implement any IoT projects. Okay, there is another poll here.
Okay, yeah, and when just before we got into that, Ravi, I did, had a question regarding the edge computing versus cloud computing, because you do hear so much about cloud computing, the processing power, et cetera. But it sounds like what you were pointing out is that it's really a kind of a balance between the two, between the actual like processing speed you need, that it's where it sounds like edge computing has the advantage, as well as the connectivity. And so is that essentially kind of the balance that you're looking at between the two?
Yes, obviously you need edge computing in a lot of cases. In some form or fashion, you need the edge computing, and also you need the cloud computing, because you cannot handle so much data in your company. Beyond that, you need to push it to the cloud for further analysis. Okay, for a quicker turnaround of data and everything, you need edge computing.
Okay, great. Thanks, Ravi. And we did just have a few folks join in with us, so I wanted to welcome them, and just to highlight, within GoToWebinar, we have. We'll be able to unmute people kind of selectively. It doesn't seem to be working across the board, but definitely if you have any questions, in the chat or in that questions pane. And then one other thing to highlight, we'll be getting in the handouts pane, you'll see there's 4 handouts. There's a couple articles. You actually have the version of this presentation. If you wanted to flip through anything you may have missed here as we're going through, and then there's an Excel workbook that we'll be using just to kind of step through the initial portions of an IoT roadmap. And so here in this portion of the poll, we've got another one. We're going to get some input just regarding a lot of what Ravi just talked about in IoT architecture, and kind of how you feel in terms of what you've understood, and kind of where everyone's at in this space. So yeah, you can go ahead and poll should be popping up on your screen here shortly. Just take a look and see what you think. So we'll let that go for a few more seconds here. It's collecting responses. There we go, starting to get a few more. As the virtual tools are great, but it does can be a little challenge on the engagement piece of it. But it's really fortunate we're able to continue to engage and hold these types of workshops even in the midst of some of the challenges. So it's a great tool to have. So it's a few more seconds here, and then we'll take a look. Almost half the folks have put in their responses. Okay, we'll call that good. And here we go, Ravi. So I think a lot of basic familiarity, getting familiar, don't understand all the details. And then a few others that are a little bit higher up. But I think it sounds like we've got a great group for the material that you're sharing today, Ravi.
Okay, thank you.
And so, again, if there's any questions, you can go into the questions pane or the chat, and we'll be watching for those. Or you can also, there's an option just to raise your hand if you'd like to talk and just share your question that way, or share anything else. So I'll be looking out for that as well. So feel free to use that, and we want it to be as interactive as we can make it. So here, let's see. Get back to that poll and navigate through all this, and we'll hide that again. So now you've got, you can reshare, Ravi, and continue on here.
Okay, thank you very much, Matt. So the next topic here is replace or retrofit. What is my path from legacy to IoT? So this is an important topic. This is what we hear from a lot of folks in the field. How do I move from my legacy to IoT? So here we are covering this topic with a few tips here, and this would really help. If you have any questions, you can always reach back to us. Like any specific questions on this topic, we can always reach back to us, like later. So here in this case, what happens is, I have been to like companies which have equipment before World War, like 1930s, right? And then there are, like some equipment which is made in 1950. They're still working great. They're producing widgets, and then people are happy, right? So there are all these equipment in our companies from 1930s until 2000, let us say, where people have not put any sensors, or they've not talked about this digital transformation and everything. But today we talk about all these. So how am I going to move? Am I going to totally throw away what I have and build a new one, spend millions of dollars to get into this? Or what is the right balance for me? That is what this topic is about. Okay, so here there is a small use case. Let us say you have a particular equipment which has a pump system, right? It is its flow is not regulated with a variable speed drive. So it means it is regulated mechanically with a valve, and then the motor runs on constant power. Okay, so in this system, you want to introduce the sensors today, or like you want to get data from it, so that you want to reduce energy and those kind of things, right? So in order to do that, there are a few options, right? You can go for a tailored modernization. We are going to talk about like 3 options here in the slides to come. Okay, so when you go ahead and retrofit the system, let us say, with a frequency converter, and when the motor can regulate the flow itself, okay, using sensors, then automatically you are going to see that there is an energy saving, okay, from 20% to 70% is what we are saying here. So in this particular case, what we are saying is you need to introduce automation, and the automation is done with the help of sensors, which automatically trigger certain responses to some sensor readings, and then automatically things change, and your energy is saved, right? So there are a lot of operational benefits when you talk about this, right? It could be increased efficiency and lower energy consumption, like what we talked. You could constantly get good data, and then you can use the data for further optimization, right? But how do I decide what is the right approach, and how do I go about doing this? Okay, so the first one is, let us say you have this huge equipment, like $1 million equipment, which may have several systems, right? Several subsystems. You may want to look at one particular system which needs replacement. Okay, so in this case, let us say you can duplicate only one component in the system, and then you can get the data out of it, and then you can use the data. So there are a lot of companies like Siemens and like a few others which can do anything you ask them. They're going to change, and they're going to give it to you. You can reconstruct the original motor with a modern standard component. This is the example we are saying here in option 1. In option 2, you can go further, right? You can change to variable speed drive. You can go from a DC motor to an AC motor, and you can go with the gearless drive, and so on. So it means you are getting more benefits out of it. So the technology builds, like as the technology is built in, the newer technologies have sensors built in, and they are automatically providing you the data and so on. So you can get data from all the components, or you can get the data from a specific component, depending on the situation. Like, for example, you need to go and evaluate whether equipment upgrades are available. Okay, if they are not available, what are the costs associated with each of these movements to replace an entire system as opposed to replace individual parts of the system? What are the costs associated with it? And then you will do a ROI calculation and then see whether it makes sense, right? Typically, what we do is, in most of these cases, okay, the equipment upgrades are not available at all. You cannot you cannot totally change some of the equipment to a newer equipment. And if you have to do, either you have to throw it away and buy a new equipment, or it's going to cost a lot to bring in a company like Siemens to make all the changes. However, technology can help us here. Okay, using like sensors, smart sensors like the one we talked earlier, and using the retrofit kits. Okay, you are able to make those changes. Like, for example, a CNC grinding machine. Okay, you want to capture data, an uptime data for an older CNC machine. So you could just put one sensor which just measures the electricity and tells you, when the machine is up and when the machine is down. So it will give you like the machine uptime. But this is not good enough because some of the use cases we have seen in the field are this just like giving me the time a machine is up is not good enough, because they want to know when the machine is up and when the machine is idle, because they start the machine half an hour before they want to do anything, and the machine is just the spindle is just going around doing nothing. It is idling, right? And then there is the setup time. You set up the job, so you want to capture that time, and then you want to capture the exact time when the tool touches the job and when the tool finishes the job. That is the actual time they want to measure, because that time really helps them to calculate certain things and then quote for orders with their customers and so on. So when you are thinking of like smart sensors and retrofit kits, you need to go to that extent to see what exactly I want to get out of this whole thing. How do I want to measure this? Do I want to measure just simply a time just by putting one sensor, or do I need like multiple sensors to capture these individual pieces and so on? This is where like if you can just throw away the CNC machine and buy a new one, yeah, everything will come there, right? Because it is able to get you all that. But as I said, the ROI is not the best. ROI is not in favor for you. So there are a lot of options available here. However, the retrofit kits that bring sensors, connectivity, and controls together, that can be explored. And even single sensors can be explored depending on what you want to get out of it. Okay. So in these cases, obviously, there is a connectivity issue in some of the factories because their network is not laid out correct. So in that case, you can explore, like the wireless option, the Bluetooth options, those kind of things. And then the capabilities of the internal teams, whether they are able to implement these kind of solutions and so on. So it is always better to partner with some companies who go through this process and make it easier for us. Then I want to move on to the next topic, which is the KPI. So even in some of the questionnaires which we got filled in and we had like some people asking about OEE, the overall equipment effectiveness or whatever. This is a very interesting topic to me, at least, because I've been at some customer sites, like for example, GE Appliances in Louisville, Kentucky. When we were executing a project in 2015, there was a huge debate going on this OEE. What exactly is availability? Like they all know what exactly it means, but should I take some certain thing as availability, certain thing as performance, and certain thing as quality? Because like what happens is, if you start like, if somebody starts dictating, saying that, like whenever my machine is available, and only if these things happen, then only I will take the thing as available. Like for example, the CNC grinding machine I was talking about, right? I will not calculate the availability from the beginning to the end, or I will not calculate the performance from the beginning to the end. I will calculate the performance from the time the tooltip touches the job and to the end of the job is finished, right? So likewise, what time should be included in availability? Like because maintenance folks, they say your equipment is always available. We are keeping it ready for you. But production folks, they'll say, oh, it is not available for us because you are constantly coming and tinkering it and so on, right? So these kind of nuances are there when you are measuring OEE. And typically all the KPIs are built around the OEE and, like the availability, performance, and quality and so on. And this input data from OEE goes into multiple KPIs in a company. Okay, so there are 6 big losses in 2 in each category: planned downtime and breakdowns and minor stops and speed loss and so on. Again, we need to properly define them. And then one of the most important things I have seen is OEE. You cannot define a company-wide OEE because then people are not happy. In a certain area, the OEE should be defined in a particular way. In other areas, it should be defined in a different way because you are using different type of equipment and different type of maintenance and operations go on. Okay, so these are some of the things I have really seen when we talk about OEE and the KPIs. So when it comes to collecting the data from OEE as also like the other KPIs, when you are looking for it, okay, so there is an evolution. So from level 1 to level 6, you go through this in 4 steps. Okay, the first thing is you just look at what you have, based on your use cases. You just try to understand the possibilities, which is step 1, which most of the companies are in. And then you move to step 2. You start taking your data, and then you start visualizing the data and see whether your data makes any sense. And then using the data, can you identify any root causes? Like the use case on the fiberglass manufacturer, what I talked about, they had a lot of data, but the root cause on quality was not actually, it was not getting addressed. But the data was, the visualized data can help them in multiple ways, but not on that particular use case what they were really looking it for. Okay, so now they started putting the vision systems, let us say, and then they move into step 3, which is you are able to detect the anomalies, and then you are able to fix the problems, and then try to optimize and improve and go further, right? Using AI, you are able to do predictive solutions. And then the final thing in Industry 4.0 is autonomously like running processes. The machines are able to run themselves, and then they are able to fix their problems with very less human effort, right? So the KPIs are geared towards that from level 1 to level 6. Okay, so this topic, AI and machine learning, this could itself be like a separate workshop, but I wanted to bring the importance and the crux of AI-based systems here. Okay, so there are 3 important things AI can do for you in manufacturing use cases. First, alert when a reading is outside a threshold range. Okay, do I need AI for this? It may or may not. If it is just one single range, like what I talked about, the valve use case, in the case of the paint manufacturer, right? All it needs is, it is out of the threshold, and you just need an alert for somebody to come and fix it. Yes, in those cases, you're using AI. But let us say you're collecting this large volume of data, right? There are so many thresholds, and each of the thresholds can be playing with the other. So in those cases, you cannot be building rules to make sure that, when a particular equipment is giving a particular threshold, there is something else going on in another equipment. So how do you link both of them, right? So with AI, you are able to link them quickly together, and then you are able to act upon that. That is where, when I said, you alert when a reading is outside the threshold range. Okay. Then with with AI, you're able to link the data between your process analytics, your product analytics, and equipment analytics. Okay, there are multiple analytics coming, right? With all this data, you are able to identify the key drivers, okay, causing the bad actors, causing the ones which are causing problems, and then you're also able to use the data to optimize the configurable values for future thresholds. Like for example, your quality, right? Your constant improvement, your continuous improvement on quality, your continuous process improvement, all that can happen using the AI and machine learning analysis. So here I just put, like the five buckets of use cases on the left, and the analytics area, which kind of covers those use cases. Okay, so finally, okay, we gave all this information. How are we going to connect all this information? And what are my next steps? How am I going to implement an IIoT project? Okay. So before we do any project, we go through the return on investment. Okay, so in the spreadsheet which was provided to you today, there is a sheet on ROI. But unfortunately, ROI, like should be specific. Actually, there are ROI calculators which are very generic in nature and they don't help. So we have ROI calculators which are configurable based on the use cases. So just by spending a couple of hours, we are able to calculate ROI using our ROI calculator. And as you see here on the left, these are some of the inputs to your ROI calculation.
So
Ravi, yes.
Yeah, I was just I know you mentioned it briefly, but just wanted to highlight again for the folks on the line. If you look on your right-hand pane, you may have it minimized right now, but if you pop that back out and look and find the one that says handouts, that's where you can find that Excel sheet, Industrial IoT Connectivity Workbook. And that's what Ravi's talked about, and that's what this portion will start to walk through. So just wanted to highlight to those on the line here. All right, go ahead. Thanks, Ravi.
Okay, thanks, Matt. So you can open the workbook and then you can take a look at it and start filling in as well. So here, our basic process in implementing an IIoT project is you start with a kickoff and go through the ideation process, the validation process, the proof of concept, and develop a minimum viable product, and then which can go into a scalable solution. So a kickoff phase is primarily identifying who's who, what kind of like problems people have, and where they are today from the as-is process and where they want to be, okay, in future. So these are some of the things we gather in a kickoff process, and what are the desired business outcomes. We just gather, and then with this data collected, we go into the ideation process. So the ideation process is generally to collect and compile the use cases that meets the business goals, which we talked about earlier. And then here, we just look at the assumptions, because whenever people are talking about their business goals, like obviously there are some assumptions and there are some risks associated with that. So we are going to take those use cases and evaluate the assumptions and the risks, and also ensure that there is alignment of the expected outcomes with the use cases which are being discussed. Then in the validation step, this is where we go ahead and actually put stuff in the ROI calculator and ensure that the ROI calculation is correct. Okay, it should be within like 10% of your actual accurate numbers, because we have already validated the assumptions and we have calculated the risk and we have adjusted the ROI values accordingly. So once the validation process happens, then we can go into the proof of concept. So the proof of concept need not necessarily mean you will build like a big solution. So let us say you have a work area with 20 different machines. Okay, so you can build a solution for one or two of them, which is what the proof of concept is. And you want to make sure that it is able to connect, it is able to get data, and you look at the data, and then you start using the data, and then telling people what exactly happens in the proof of stage. So during the proof of concept, people are going to come back with questions, and they're going to reevaluate their own assumptions, and there may be some changes, right? So once we go through that and we verify the technical feasibility and the requirements are met, then we build a minimum viable product. Again, the minimum viable product could be just for one work area. If you have like 100 machines in your factory, the same kind of machines, one work area may have only 10, let us say. So you are going to build the minimum viable product for that one work area, and then ensure that you go through that, you deploy it, and you understand the problems, and you understand the process, and then you can scale it out to other areas. Okay, and then you can do this for each of the use cases. One by one you can take, and then go for the use case. Okay. So people 4.0. This is like a very important topic. When you move to Industry 4.0, the concepts are a little bit new, and in some cases people are not aware of how to go about doing it, and in some cases they know, but they're not able to move forward, okay, because they're stuck in the past, right? So the most important thing is you want to ensure that there is a learning potential for your people, and then you create a learning journey for them to move to your Industry 4.0. And then when we go into any factory, we see like people of all kinds. Okay, like for example, you have the millennials, okay, who wants everything automated, and no amount of automation is enough for them. And then you have the people who are about to retire, and they don't want to touch computers. Okay, so there is all this kind of people, right? And but what we need to understand is there is tribal knowledge. All these people have enough knowledge, which is what is carrying out your process today. So your product quality is in their brain. Your process knowledge is in their brain. So we don't want to really get rid of the knowledge just by quickly automating things. So we got to develop a way we capture the knowledge, and that is built into the process as you go along. Okay. So one thing which I have learned is from my own experience dealing with maintenance folks who really like to do maintenance. Okay, they don't like to go and enter data into the ERP system, because if they do maintenance, they need to tell what kind of problems they solve, what kind of parts they fixed, and they need to write a small story about 5 lines or 10 lines about that particular piece of work they did, right? So typically people don't like that part, and because of that, even after you implement large ERP solutions, companies don't get enough data to act upon it. So one thing I really learned was these people like to talk. Okay, so using your products like Alexa and Cortana and all that, you can just ask a simple question. Hey, tell me about what you did today. What kind of parts did you use? What kind of procedures did you follow? So they can just talk, and which can be recorded. That particular information can be recorded, and then it could be parsed and made into information in the way you want it to do. Okay, it is not necessarily people are resisting automation, but they just resist, very boring job, or they just don't like some part of the job, which is entering data in paper and so on. Okay, so change management is the most important part. From the top, your C-level executive, and to the people working on the plan for, everybody should embrace change, and everybody should embrace change. And in order to do that, so the change management process should be properly implemented in a company. Okay, and I stop here, and then we have time for discussions.
Yeah, thanks, Ravi. Diff, I'd put a note in the chat, and Diff, if there's anyone who's got a project you may be working on now, I can maybe raise your hand or send a note in the chat. We'll unmute, and I can go ahead and let's see, try to unmute everyone again, but it looks well. Let's see. Yeah, I think so. I'll try to go through, and you at least will have control if you do want to share anything. You should just be able to go unmute yourself now. So I know we had a number of folks respond in the surveys. Some were talking about how to, when they have manual work, but how they can still, essentially digitize manual work, and what options there are around there. When you have maybe manual assembly processes where there is no, easy sensor per se to get there. Some other things, folks were, on how you implement, IoT in a cost-effective way for smaller shops, or just being able to respond to product and process issues in a more timely fashion. So I think those are some of the other areas where folks were having some projects. So anything anyone would like to share?
I'd especially love to hear from someone, if there's someone who responded to say that they have trouble justifying the cost, but that the use case wasn't the biggest challenge. I'd love to hear about an example of that, where there's a definite need or a use case, but the cost isn't necessarily justifiable.
And let's see here, look through some of the other, here, we did have a couple of the last polls that we can do in the meantime while folks are thinking it over. Well, I think it was just really follow up from the beginning, but we'll get the current view, but where, from a challenge standpoint, where do you see it as most applicable? And I think we did have a few folks that joined in after this one, so maybe we'll get some additional input. So you should see a poll pop up on your screen here shortly. You identify whether it's on the manufacturing and maintenance operations, or product focused around quality or design, or aftermarket support and service, or you're not quite sure. So I'll leave that open for a little while longer.
One thing also that I wanna get out to people before we wrap up, on the workbook, you'll see in the 5th step about ROI, specifically around that question of justifying cost. We developed, and we already have quite a number of use case specific ROI calculators. So if you, and my contact information will be up on the last slide, but if you want to reach out, if you're exploring a use case and your challenge is justifying cost, give us a call, because we can work with you on creating a real cost justification or ROI calculation specific to that use case and specific to the problem areas that you're looking to address.
Yeah, absolutely. And I put up the results of the poll. We had half the folks that are with us voted. So a couple for the manufacturing and maintenance side of things, and someone for product design, which I'm interested how how that would be implemented. We have maybe some folks that are more in the engineered, highly technical products, that have a lot of aftermarket support requirements, perhaps in that space. So I'd be interested to know if that's something that you're doing now, or just looking to expand, or haven't quite gone there yet. So again, if anyone, it looks like everyone is just self-muted. So if there's anyone that would like to share some further context, just with the unmute yourself, and you're able to chime in or through the chat. And let's see here, we had one more while people are thinking that over. Switch. Okay, that's the same one. Okay, just looking over. All right. So yeah, any questions that anyone would like to share either through the chat or otherwise? Again, just unmute. But I think if nothing else, we'll turn over. But we'll wait a minute here and let people think it over. Okay, well, not seeing anything. As Will said, there's contact information. Obviously, reaching out to myself and my colleagues here at Catalyst, and then you also have the information for Ravi and Will. As we're certainly both organizations ready to support however we can your exploration of this topic. So we'll hand it back to Ravi and Will.
Yeah. So are you able to see my screen right now?
Yes, we can.
Yeah.
So Will, you want to summarize this? Or?
Sure. Yeah. So I don't think I need to dwell too long. Hopefully, for anyone who joined late and wants to talk about any of these early pieces that you might have missed, I think there's a recording happening, but also we're happy to talk through any of this. But hopefully, what you got out of this, as we stated from the outset, was really a good overview of the key concepts. And I really appreciate everyone who's stuck with us, because it's a lot to, it's an understandably daunting task approaching smart manufacturing, but so important, I think, as you'll have seen in the use cases that we talked about, and some of the rewards that people see out of these implementations, the things that they're able to do, the new revenue streams they're able to create. And so I really appreciate Ravi taking us through this, taking us through the use cases and the technology piece, which, again, if you're in IT, can be bread and butter. But for folks who maybe understand the plant process really well, understanding logistics of, how would you network this all? How would you even go about collecting the data? There can be a lot that needs clarification or support. And that's where a company like Hamiltonian and others working in this space are so important as partners, picking a good partner to help you navigate that side, and bringing your full expertise, because you know the most about the business, the challenges, and that will be what illuminates really where this technology can bring the most value. And so I will say, just as a final piece to that, take a look at the workbook, I think especially afterwards, and see whether that is something that's going to help you bring that internally to your company to say, here's our starting point. Here are the challenge areas, perhaps some of which are mentioned here, but also take a look at the handouts and attachments that are downloadable from the sidebar right now. And here are just a few. This is a good slide to show just a few of the things that Hamiltonian specifically has worked with our customers on. And so we do both the consulting side of helping manufacturers figure out how to access this technology, but also the delivery, and that includes bringing in software, whether it's the platforms around IoT that we have built that we customize for specific use cases, or if it turns out that there's a platform that best fits a specific case, we really look to be filling in the gaps around technology expertise and digital transformation in manufacturing. And so, depending on the specific case, that could mean creating the right dashboards for KPIs and single screen views. That could be developing continuous improvement processes and something that can year over year develop new ROI and keep increasing the value, or something like machine learning that does get at that as well, which is a long-term engagement of really tearing through data that then allows you to automatically pull insights, improve processes or products. So this gives you a good overview of, in this space specifically, what we're out to do. And really what we want to do is help manufacturers through what is a difficult and trying time, not just because of COVID, but also because of a myriad of other factors. And I understand, from all of our work, how much it is a daily grind that rarely gives an opportunity to pick your head up and think about technologies like these. So hopefully what this did today was give you a chance to do that. And, COVID more broadly maybe gives you a chance to think about that, think about how you're going to come out of this stronger. And we are more than happy to be a part of that. And so, Ravi, if you change to the last slide, you can see both Ravi's contact information and mine. Do not hesitate to reach out, email or phone call. And we'd be more than happy also to talk specifically about use cases and about justifying that, creating an ROI calculation that you can bring to your company to explore further.
Okay, well, with that, I definitely thank you, Ravi and Will, for your time to share with us today and going through your overview on IoT and this Smart Factory workshop. So just, again, you have their contact information as well as that for Catalyst. Feel free to reach out to myself or any of my colleagues that you may be already in touch with for more information and help on how we can help you take the next steps. So just one last check. Don't see any questions, but just reach out whenever. So thanks again for everyone for joining in. And have a great afternoon.
Thank you, everybody.
Thanks all.